Okay, have a look at this uh, question here. Okay, so in this question, um, now I think I'm in trouble. Yep, all right. Did I? Yep. Ah, yeah. Here it is. Okay. So, yeah, have a look at this question. We have a stopping voltage for photon. Stopping voltage is the maximum kinetic energy. It's related. It's not the same. It's related of a frequency of light. Okay, is this. Okay. Okay. We need to find the stopping voltage and when the work function is this. Okay, just use the equation. Kinetic energy is basically the total energy applied by the photon, HF, take away the work function, which is the energy required to, yeah, the energy required for the electron to escape. And the leftover is the total kinetic energy left with the electron. Put it in. Now, the thing you need to remember is, when you do this, make sure all the units is in electron volts. Okay, so you have H times F, okay? And when you use H, use the, the constant with the unit of electron volts. So take away 2.1. Okay? So after you doing your calculation, you get a number in electron volts. That's the kinetic energy. So the stopping voltage is whatever the number is and change the unit to watt. Okay? Now, because the kinetic energy tells us the energy on each electron, okay, in electron volts, and this is basically the voltage. Okay, yep, there. Yeah, the voltage of that electron. Okay, in voltage. So just remember the unit thing. Okay, the other thing, the last example we have is this. I have the photoelectric experiment and I conducted it with X, Y, Z, X, Y, Z light. So what can I conclude about this light? So if I have a look at here, both X and Y have the same stopping voltage. So V stopping for X is the same as V stopping for Y. This tells us, this is an indication that the maximum kinetic energy of an electron when X shined on the metal should be the same as the maximum kinetic energy of an electron of Y shine on it. Okay? And they should be in the same frequency. Frequency of X has to be the frequency of Y, not HF. So the frequency of X must be the same as frequency of Y. Yep. Because yep, maximum kinetic energy is proportional to the frequency. Okay, given that the work function is the same. If the work function is constant, then what I mean by the work function is constant, it means if I'm using the same metal, okay, if I'm using the same metal, then the maximum kinetic energy has to be proportional to the frequency. Okay, that's it. So in this case, they have the same stopping voltage, they have the same kinetic energy, so the frequency must be the same. Okay? However, the frequency of Z has to be less, must be less, a lot less than X and Y, okay? Because it has a lower stopping voltage. Okay? Remember, in the graph, the stopping voltage is 0, so we have a minus something there and a minus something there. Okay? The magnitude is much smaller. Now, and what I can say about the light intensity is, okay, remember, okay, the current is an indication. Current is an indication of the light intensity. Y and Z, they have the same current, okay? So the intensity, yep, I write down IN for intensity this time. Okay? The intensity of Z must be the same as the intensity of Y. And X has a much higher current. Okay? So the intensity of X must be greater than the intensity of Z and the intensity of Y. Okay, so that's my conclusion reading from the graph. And if I need to answer the question, which one of the following statements true? So the light for Y and Z has the same frequency. Y and Z has the different stopping voltage, so this is wrong. X was brighter than Y. Yeah, X is brighter than Y because X have a higher light intensity. And Y and Z have the same frequency. Yep, that's what we concluded. And Z was brighter than X, so X is brighter than Z because X has more current. So this is wrong.